Hi, this is Manoj Yadav and you are watching Mechanotherapy. So guys, today we are going to discuss a very interesting problem on free body diagram. The question is, a smooth cylinder of radius 10 cm resting on a horizontal surface supports a bar AB of length 30 cm. So the length of the bar AB is given as 30 cm and the weight of the bar is 50 Newton. So this weight of bar AB will act at half of length, that is on half of 30, that is 15 centimeter. This weight of 50 Newton will act. Now a cylinder is kept from rolling away by string OA. OA is the string by which this cylinder is attached, and the length of OA is 20 centimeter. Assuming all surfaces to be smooth, calculate tension in the string. So this is the question. Now from the problem you can see that there are two objects. One is the smooth cylinder and another one is the rod AB. So for solving the problem we will take the free body diagram of both the objects individually. So let's take the diagram. You can see in the diagram, which is in the rightmost side, you can see length of the rod is 30 centimeter and the point of contact of sphere with rod is at point D. So we will have to find out the value of AD. Now from the figure you can see radius of the sphere is given as 10 centimeter and length OA is given as 20 centimeter. So if we assume the angle theta, we will get sin theta equal to 10 by 20, that is sin 30. So we will get theta equal to 30 degree. Now when we get theta equal to 30 degree, we will in triangle OAD, this is also similar triangle, we have the dimensions as 30 and 10. So the upper side angle will also be 30 degree in same manner. So the angle of rod AB with horizontal will be 30 plus 30, that is 60 degree. Now we can find out the value of AD. The value of AD can be found out as AD equal to OA cos 30. Okay, so OA is 20 and angle is 30, so you can get the value AD equal to OA cos 30, that is 20 cos 30. So AD will be 17.32. Now once the value of AD is known, we can find out we can draw the free body diagram of the rod. So on this rod, the reaction at D point will be perpendicular to the rod at point D RD. Weight of rod 50 Newton will act at half of the length, that is 15, and the D point is at 17.32 from point A. Now let's take the moment of all the forces about point A. So when we will take the moment of all the forces about point A, the value of the moment of tension will be 0. 50 Newton will try to rotate the rod in anti-clockwise direction, so its movement will be positive. So 50 into 15 cos 60. Similarly, RD will try to rotate the body in clockwise direction, so its movement will be minus RD into 17.32. So in this way we can find out the value of RD, which is equal to 21.65. Now from the free body diagram of roller or cylinder, you can see three reactions or three forces are there. One is RC or RE, which is perpendicular to the horizontal surface. Another force is RD, which is known to us, which is 21.65, and another force is tension T, which we have to find out. Angles of these forces RD and T with horizontal are 30 degree and 30 degree. So if we apply sigma fx equal to 0, we will get T cos 30 minus 21.65 cos 30 equal to 0. So T will be equal to 21.65. So this is how we can find out the value of tension in the given string. I hope you must have enjoyed the video. Thank you everyone.